All right. So let's talk about this. How many of you actually have the definition written already for linear expression? Huh. I just put it up there, so didn't give you much time to do that. All right, for those of us that have it written, great. If you don't, let's get caught up here. So up to this point, guys, we've been talking about how to simplify algebraic expressions. Well, that is code, or that is another name for simplifying these linear expressions. Linear expressions are algebraic expressions in which the variable is raised to the first power. We haven't done really any non-linear expressions to this point. So they're talking about expressions that look like 2x squared plus 4x minus 9, something like that. That's not a linear expression because the variables aren't all to the first power. So after grading the quizzes, they look good for the most part. Some of you guys did very, very well. In fact, what happened with the quizzes is that there was definitely the one bonus point, and then there was another question right above it that I decided to make it a bonus question even before I started grading your quizzes, just because I read it and I thought, you know what, they should be able to get it, but I don't know that I went over that enough, so I offered it up as a bonus. So you potentially could have earned 2 bonus points, and some of you did get 2 bonus points. Some of you, you'll notice on your score, you got more than 18. It was worth 18 points. Some of you ended up with a 19 out of 18 or an 18.5 out of 18 or something like that. So that's great. So if you're looking at your score on dashboard and you're wondering if I had lost my mind, like why is my score more than the total points? Well, that's why, okay? But unfortunately, some of us are still struggling to understand this concept. And today will be a good day for us to just kind of review it. Tomorrow, I think I'm going to take a day and make it more of an individual type day, where I try to find where each of you are ability-wise on these skills and give you some sort of like individual task. And it's probably going to be like an IXL type thing, or maybe even a Khan or something with the iPads where you can work individually to get all of that information. Because with what we do here, guys, everything builds on everything else, okay? So what we do today is going to impact what we do tomorrow. What we do in Unit 1 impacts what we do in Unit 2. Other subject areas, you might take a test in a particular area, and then you move on to something completely different. For us, fortunately or unfortunately, it all builds. So if you're not getting this stuff right now, it's not only going to haunt you today, it's going to haunt you in the days and weeks going forward here. So I want to make sure we're all caught up. So I'm going to take a step back here. We're going to go back to the basics, and I'll try to go through this quickly with you because we have done this multiple times. But if you look at this example 1, this expression, this is an example of a linear expression because everything in here is to the first power. But if you notice the parentheses put in there, you may be wondering why those parentheses are actually even in there, because everything's addition. And you also notice that there are no numbers outside of those parentheses that we need to distribute. All right? And that's true. So what that means really is that we could remove those parentheses and it's not going to alter the expression at all. So this expression here is the same thing as saying 4x plus 5 plus this quantity 3x plus 7. For the purpose of simplifying it, I'm just going to remove those parentheses and we're going to get to this point right here. All right, so let's go quickly through this again because we know how to use these tiles. So how am I going to model 4x plus 5 and 3x plus 7? You guys can be sketching it on your paper real quickly, but tell me so I can build while you're writing. Can you tell me what it's going to look like, please? Jonas? Go back one step. Don't simplify it at all yet. Just go very basic. Okay, so 4x's would be these green bars, right? So I have 4 of these. Well, yeah, how about this, Jonas? Let's do it like this. Let's say just that highlighted part right there. Tell me how to build that. Don't worry about the other part yet. How do I build 4x plus 5? Yeah, 5 blue ones, right? So there's 1, 2, 3, 4, 5. So there's 4x plus 5. Now we're going to add on, Jonas, I'm going to stick with you. What? Three x, and then what was that? I gotta leave that. Okay. Now, put it together like you tried to do initially for me. What's that gonna? You add your like shapes, your 4x and your 3x, 7x. The 12 singles, right? Exactly. And I agree, guys, but here's the thing. This is what's happening sometimes. I'm still seeing people that'll take this expression, and I think you probably know where I'm going to go with this, and we're going to take this and we're going to say, okay, well, that's the same thing as 19x, because you took 7 plus 12 and you got 19, and you just threw the x on at the end. Hopefully you're looking at that thinking, why would you do that? You're right, you wouldn't do that. Okay, but for those of us that looked at that and thought, well, shouldn't it be 19x? Let's talk about why it's not. Can anyone describe to us why we cannot do this? Why in your mind do you think we cannot do this? Go ahead, Cameron. Yeah, I like that answer. What she did is she said this second, she's like, you don't know what x is, but then she also said, well, if x was 5 and you put that in there, then it's not going to be the same thing. And she's absolutely right. Good. Marco. So you're saying they're unlike terms, absolutely. Exactly. Right. So without knowing this, and you know another thing, it's like saying, okay, I've got 7 of these green bars and 12 of these blue tiles. Isn't that just the same as saying I've got 19 green bars? No. Anybody go trick-or-treating last night? If you didn't, then why not? Come on. Right? It's your free chance to go get candy. So this would be like this. This would be like, all right, what, Snickers bars? You guys like Snickers bars? All right. I'm going to make the executive decision right now, and I'm going to call these green bars Snickers bars, all right? Let's assume you like Snickers bars, all right? So it's like I've got Snickers bars, I've got 4 of these Snickers bars, and I've got 5 of these boxes of Nerds or something like that, which is garbage, all right? So you got these 4 Snickers bars, 5 boxes of Nerds, 3 more Snickers bars, and then you go to another house and you collect 7 more boxes of Nerds. What you're telling me here that you guys just did, well, that's the same thing as just having 19 Snickers bars. You kidding me? No way. 19 Snickers bars, that's not the same thing. That's 7 Snickers bars and 12 little boxes of Nerds, right? It's not the same. So you can't push those together and call them the same. So if you have to think of that, go ahead. I don't care, but like whatever works. Let's look at example 2, or letter B rather. No, on this one you don't have to draw this, but let's just talk about, I'll build it. You can help me with this. I've got a new bar that's, I didn't say bar because I just used Snickers bar, but I meant bar like in red bar right here, okay? This red bar represents a negative x, okay? You didn't have these when we were building them before, so I'm just modeling them. So if it says negative 3x, guys, I'm talking about 3 of these red bars. Negative x, negative x, negative x. That's negative 3x. I add on 8 blue tiles. Now, I'm not going to actually draw them all, but you guys can work with me on this. Plus 8 blue. Then it says plus a negative 2x. So I'm bringing 2 more of these blue, or I'm sorry, red bars, plus 2 blue cubes. So when you put all these shapes together, all these different candy varieties, or however you want to think of them, what do you end up getting for your simplified expression? Emma? I've got 5 of these red bars. Each one's a negative x. There's how we get negative 5x. We've got 8 blue cubes, 2 blue cubes. That means we have 10 blue cubes. We're not pushing these together and saying, oh, well, that means that we have negative 5 plus 10 is 5. Oh, that's the same thing as just having 5 green bars. They're completely different. No, we have to stay here. And this is probably restating the obvious to a lot of you, like, oh, yeah, that's what I've been doing. Good, keep it up. But for those of us that might have wanted to do this up here, that's what I'm trying to emphasize for you, okay? All right, let's do this. These U tries down here. You're going to do both, but you're not going to check with me first. You're going to check with your partners first. Once you guys have agreed on an answer, then call me over and I'll verify it with you, okay? So I'm not the first check. Check with somebody first, please. Go ahead. First one, which is actually number 2. All addition. So everything's addition, so you could just drop these parentheses since you're not distributing anywhere and combine your like terms. What did you and your group decide upon for your answer for number 2? Simplified, of course. What do you have, Lauren? Agreed. Negative 2x plus 13. Your x's get paired up. Your constant terms get paired up, and you're just adding them together. Number 3, the only difference here is that you had a subtraction. How many of you made the 4x minus 3 plus a negative 3? Most, but I'm not seeing everyone, and I want to see everyone on this one, okay? So we got this, 4x plus a negative 3 plus negative x plus 5. What does that combine to give us? Weston? 3x plus 2. Good, let's turn it over. And let's talk about a concept that I was kind of blown away by when I was grading your quizzes. We had reviewed perimeter, we had talked about perimeter, we'd done examples with perimeter. However, when it came time to finding perimeter on this quiz, a lot of us seem to have forgotten what it was. So explain to me quickly, briefly, what is it? What is it, Marco? Like the length of every side? Yeah, he said every side. Our biggest fault was that we weren't doing every side. We were doing One side, two sides, three sides. But if it's a rectangle, that's a problem, okay? Because a rectangle has four sides. So you make sure you get every side. Now we're going to start with a triangle here. And I know your triangle doesn't look the same as my triangle. That's fine. It doesn't matter, okay? It's just any triangle. So let's fill this in. It says let S represent the length of the first side of the triangle. Okay? First side. Boom. S. And you could put S somewhere on the shape. I don't care where it goes. All right, the second side, it says, is 3 more than the first side. How am I going to write that expression for the length of the second side? This is what we were working on last unit with writing these expressions. Riley, go ahead. S plus 3. Pick another side, and you can label that one. And the third side here, in green, is 4 less than 1.5 times the first side. Again, something we've been working on. How do I write 4 less than 1.5 times the first side? Go ahead, Zoe. Close, but not quite. You want to do 1.5 times the first side. You're multiplying 4 times 1.5, but you want to multiply the first side, which is S, by the 1.5. So it's 1.5 times S, which is 1.5S, minus the 4. 4 taken away from 1.5 times the first side. That was a little tricky there, but again, we've seen these before. So perimeter. Again, just to re-emphasize, perimeter isn't this. Perimeter isn't this and this. Perimeter is all of it. So when you write your expression, it's your first side. It's your second side. It's your third side. Notice how I changed the third side to plus a negative 4. That's the expression to find your perimeter. The simplified expression is just get to your like terms all joined together. So 1S, 1S, 1.5S. So your like terms are here, here, here. Your constant terms here and here. What is all that going to combine to equal when we combine like terms? Let's get this one before we go. What do you have, Natalie? It is 3.5S plus a negative 1. Good. All right, guys, I'll see you tomorrow.